Hello, everybody. I'm Bart Massey, as always, and as always, welcome once again to CS300 Software Engineering. Hope you're all staying safe and well out there during this difficult time. Today, we're going to be talking about software project management, which is an interesting thing to start with, but maybe getting some of the ideas out there will help us understand more of what the software engineering process is like and sort of how it can be. So with that, let's go ahead and dive into that and talk about that a little bit. So what's a project manager? We usually call them PMs in industry for short. It's somebody who does planning for your product or project. It's someone who says, at least at the high level, what direction the development's going to take. The marketing of the project, they may at least interface, the project manager may at least interface with the marketing people, or in a small project they may be the marketing people, which is an interesting and problematic thing to have the PM doing, but there we are. They interface. Their biggest job maybe is to be the interface with the team, the people who talks to the person who talks to the team, the person who talks to management, and the person who talks to the customers. And so they are the common point of communication for all these things, and that's a big part of what they handle. Finally, typically the project manager is at least a little technically engaged in the details of the project. They should know what's being built, how it's being built. And so this is a demanding skill set. Typical situations, a project manager is going to be somebody with at least 10 years of experience doing software development, and it's an interesting problem because people who've done 10 years of software development often don't want to do management instead of development, but that's typically the way it goes. An interesting opportunity is our capstone that's coming up for many of you. In CS Capstone, we train several of you as volunteers to be project managers because we need project managers for our two-term capstone projects, and that's a chance to get a taste of these activities really early if you're up for that. Something to be pointed out is that project management is what we call a full life cycle activity. That is, a project manager typically starts before the product features or requirements are even established, and typically doesn't end until the software goes out of maintenance. It's kind of a full-time job for as long as the software project is live. And for smaller projects, it's very possible that there isn't enough on one project, although you look at all these things and you wonder how that could be, to keep a manager being full-time. So it may be that the manager is also a part-time developer. It may be the manager is also managing some other project or product elsewhere in the company. Those kinds of situations do happen. Notice that being a project manager is kind of a balancing act. You're being asked to sort of represent multiple different things at once. You are the person who's going to make sure that the business that's developing the project gets their needs met, because that's really important. You know, the product, if it's a product, needs to pay the bills. The project, if it's a project, needs to fill the company's needs. So that's a thing. You're the one who needs to ultimately be the arbiter of what technology and development constraints have to be respected. So, you know, what languages can we use? What tools can we use? How big of machines do we need? All that kind of stuff. You're going to have to sort of figure out what you need and want there, and that's going to balance against the business needs. The customer has their own set of needs. If it's a product, you're sort of balancing what is it we can sell and what are the needs of the general community. If it's a project, you're this specific customer's requirements. And so you need to balance all that with those first two things. And finally, you're the owner of the team, so you need to balance the needs of the team itself. You know, are they overworked? Are they comfortable technically with what you're doing, etc.? That set of needs to be met as well. So you have these things you're all balancing off against each other, and it gets to be pretty balancy. It gets to be a little bit of a tricky thing to do, and I think a lot of people find it quite challenging. One of the things you typically have with a software product is a roadmap, and this will be typically one of the documents that's authored to some large degree by the project manager, by the PM. A roadmap is a metaphor, obviously. It's not literally a map of roads, but it's a good metaphor. It describes the features for a product that feature might have. It describes what we call milestones, goals, specific things that we actually want to get done on the project. And, the milestones and roadmap sort of go together. So, what is it you want to get done? A list of features, a list of whatever. Then it's a roadmap will also specify timing. When should we achieve each of those milestones by? What's the sort of latest we'd like to see those things happen? So we look at the features, set out these milestones for the project. We look at the deadlines that those milestones should meet, and that's our roadmap. And one side effect of that, we haven't really talked about Scrum or Agile development, but what it does is it produces what we call an initial backlog. It produces a bunch of things that you need to do first. And at the end of that roadmap, you look and you may not know exactly what you're going to have to do all the way along, but you have a pretty good idea of how you're going to get started on this project. And that's one of its important roles. When we talk about requirements, whether it's a product or a project, you really need to think about what does this software need to do? What is its role? What is its thing? And there's sort of two kinds of information about how the project will be used or the product will be used that you typically gather. You gather what are called user stories and scenarios. And the idea of a user story is that it's a very general description of the ways the product will be used. So for Sugar Mantra, my user story might be, I have puzzles and I need to get anagrams so that I can find one with the right number of words, or the right longest word or whatever to solve this particular word puzzle. That might be a user story. A scenario is super specific. It's like literally a script that you go through. In that story, I say, well, I'm going to take Sugar Mantra, my anagram solver, and I was told on March 12th that I would need to find the anagram with an anagram with the longest word for the phrase Barton Massey, and so I ran the software, and within 5 seconds I had out a list of all the anagrams with a word longer than 8 characters, and the longest was a 9-character word, and it was this specific word, which I don't know what it was. The scenario you can't always fill in all of, and I was successful and went on my way. So that kind of thing, the user stories and the scenarios, we're gathering to get a picture in our heads of what is this software going to be when it's built? What is it going to look like when it grows up? And that's a really, really critical step, and it's a really easy step to skimp on or skip. And if you do that, if you skimp or skip the requirements phase, you'll end up with a piece of software that does a thing, but it won't necessarily have much relationship to a thing that anybody would care about, including you. And that's a really easy trap to fall into. I used to advise a lot of tech startups with the Oregon Technology Business Center, and probably the number one problem from my role as technologist that I would see is people coming in with these very fancy technologies that were solutions looking for a problem. And that is a very common mistake to make. You really want to go problem first, or if you're building a product, you really want to go features first. What does this need to do to meet a need in the marketplace? And then you narrow it down. You say, well, specifically, what would be an example of using this software, and what would be an actual script that you might run through while using this software? And after you've done that a while, you're like, okay, now I know what I need to build. Another critical thing is to decide what the interface to the product would look like. We talked earlier about the fact that software doesn't exist in a vacuum. We build software-intensive systems, and so the interface between the software and the rest of the system is an absolutely critical piece to think about, and again, an easy one to forget. And those interfaces tend to come in two forms. Either I'm building the software to interface with users, in which case I have to think about what the user interface is going to be like, or I'm building the software to interface with other software, in which case I need to think about what the application programming interface, the API, looks like. Or sometimes for larger projects, both. They both are a user interface and, both user facing and software facing, and I need to think about both. But designing that piece is trickier than it looks, is more important than it looks, and you should make sure that your user stories and scenarios make sense with that, and you're going to want to do some prototyping, which we'll talk about shortly, for doing that. The other thing that's super easy to forget is that not all requirements are features. Not all requirements are about functionality. So we have what are called the ilities floating around, which are sort of qualities that the software needs to have that aren't so much what do they do, but how do they behave. So for example, has to fit within the memory of this particular computer. That's not really about the function, it's just about will this work at all? Or has to be, it has to produce an answer within 3 seconds. Again, not really a functionality thing, it's just, if the answer is not in 3 seconds, it's worthless. So for example, in the design of emergency management systems that 911 dispatchers use, a 911 dispatcher will get this software, and if doing whatever query you need to do with this software takes minutes or half an hour or whatever, which is a real thing that sometimes happens with these systems, no point really in having the software at all. Doesn't matter how good the answer is when it comes back. You really have to be able to produce it in seconds because somebody's life might be literally on the line. The other thing that you need to think about when you're thinking about management is quality management, and that's going to be another job the project manager is going to have to do. So at the front end, the project manager needs to think about the requirements. At the back end, they need to think about the quality of the result. And you need a plan to be in place as part of your project management to measure the quality as you go and again at the end. We generally just cut this into sort of 2 different kinds of things. One is that the project meets the requirements or has the features or whatever that we specified for it. We call that verification, and that's super important. The other thing we do is say, well, maybe it meets the requirements. Maybe, in the words of an old parody poem you can find on the internet, it's just what the customer asked for, but not what they want, right? We've developed these requirements. Maybe the requirements are no good either. We also want to validate. We want to make sure the product actually does something useful or does something productive, does something saleable, meets the requirements of some project, whatever, meets the needs of the customer or whatever. And that's validation. Together we call those things verification and validation, V&V. And V&V is a big deal and can be a big part of the project and does need to be managed. There's sort of 3 general methods to preview a little bit for V&V. We can inspect the product or project. That is, we can look at it and see whether it seems right. And usually having someone other than the developer do that would be a good idea. We can do the thing everybody does all the time, which is to test the project. We can define some things the product should do and then see if it does them, or pieces of the product should do and see if it does them. The third thing, which you don't see very much but is important in some situations, is what's called formal methods, which means here using math and logic to actually prove properties of the system so that you get a very solid handle at very great expense for what is this doing and is it doing the right thing. So that's a lot of what software project management looks like. I need to manage the product or project end to end, software product management, software project management. I need to manage end to end all these different things and keep all those balls in the air at the same time. So it's one of the most challenging things you can do as a software developer, as a software person. And the common thread here, I think, is at the end of the day, like I've said before and we'll say 100 times more, this is people. It's all about people. It's all about the manager as a person being someone who interfaces with all these different people, customers and potential customers and management and the team, and deals with all the vagaries of human needs and human wants and human behavior and emotion and all the problems of human fallibility and human confusion that are the thing that makes software hard. And so it's an absolutely crucial job. I think that's what I have for you today. I hope that was useful. Thank you very much for listening, and I look forward to talking to you again soon.